Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video we'll go for the what is the uniqueness of a matrix here, because in the previous video we have done the what is the invertible matrices, so which states that AB is equal to B is equal to, that is identity matrix, when we are having a two matrices which is of a same order. Now here in this case what happens when we are taking some matrix A, B and C, means what? So suppose I am having a matrix A which is of order M, and the same time there is a matrix B is there and the matrix C is there. So this matrix B is inverse of A, as well as this matrix C is also inverse of A. So means what? This matrix A is having two inverses, like B is also inverse of A and C is also inverse of A. So at that time, so this matrix B and C, whether these two are unique or not, so we have to prove that one. We have to prove whether it is same or not. We have to conclude that one. Now let us move on to this one, whether this thing B matrix B is matrix C is or same or not. Now how we can able to prove? For example, if suppose if A is a square matrix, so because we have studied the invertible matrices, by the definition of the invertible matrices we'll just have some equation, we'll just go through here, or whether to prove that this inverse of a matrix is unique or not. So in that case, if suppose I am having if A is a square matrix and B is a inverse of A, so which means what? A is a square matrix and the matrix B is a inverse of A, means what? I can write this as like this, that is AB is equal to I. So again, even if you take the product of this B into A, then also I am getting, so the identity matrix, that I can write it as AB into BA is equal to, both I am getting the identity matrix I. So this is what one of the proper by invertible matrices condition. Okay, now this is what we are considering A and B. On the other hand, what I am having one more matrix C, that is also inverse of A. I'll consider here. So same here, if A is a square matrix, if A is a square matrix, okay, and C is a inverse of A, again there is one more C matrix which is also inverse of A. So then I can write this with the help of invertible definition like this: AC is equal to CA is equal to I, right? Now we just prove what we have to prove. So we need to prove that, so whether this B is equal to C, because these both are B and C matrices are what? So these are the inverse of A, both the matrix this both matrix B and C are inverses of A. So that's why we have to prove that whether this B is equal to C or not. Okay, now from this, AB is equal to BA is equal to I, so here it is a AC is equal to CA is equal to I. So what we have to prove? This B is equal to C, I have to prove here. Now I will consider the left hand side part. I will take, this is a B. So now this B I can write it as, so B into I, by the definition of the identity law, means what? We can multiply this identity matrix for the any of the matrix, so that we can get the same matrix itself. Okay, now again what I will do here, so this B, okay, let it be, in place of I, shall I write like A into C? So I'll write this is B as it is, in place of identity matrix I, I'll write this A C here. Now again I'll just take these two separate terms, that is B A, this is C. Now again what happens? This B into A is nothing but what? From this equation. So this is also identity matrix, I'll write I here, this is C. Now again what happens? This I into C is nothing but what? This is C itself. So the left hand side part is B. So means what? That is the B is equal to C. So finally, once if you are having the matrix A, so this matrix A is having some inverse B, sorry, the two matrix B is also having inverse of A and C is also inverse of A, means the matrix B and C both are same, that is the unique here. So this is a very important, that is the inverse uniqueness of a matrix here. Based on the invertible matrices and the uniqueness of a matrix, so we are having some important property here. So this is a property what we have given here, that is a AB, that is a inverse of A into B, that is given by B inverse into A inverse here. Okay. So this is a very important property, and this is a simple one. This is not the tough one, easily we can prove here. So sometimes there may be chances of asking for the examination point of view. Now we have to prove this. So because this property we have derived based on the invertible matrices and the uniqueness of a matrix here. Now I will just consider this first here. So this A B inverse is equal to, okay, this AB, okay, for example, before that I can write A into A inverse is equal to what? This is I, right? Because of the definition of the invertible matrices. So A into A inverse is equal to I. Now even if I multiply this AB, if I take AB whole inverse is equal to I itself. Why? Because this AB is also one of the matrices here. So inverse of this AB is also, we are getting what? It's a I. Similarly, what I'll take here, I'll just take this part, that is a AB into AB whole inverse is equal to what? The right hand side I can take, it is identity matrix I here. Now the next step what I'll do here, I'll multiply the A inverse on both the side. So but the thing is what, that A inverse I have to multiply at the starting here, that is the, we have to pre-multiply the A inverse. So I just take the A inverse AB, so this is AB whole inverse, that is A inverse into I. So how we are getting this? By pre-multiplying A inverse, because in the multiplication it's a very important, that placement is also important. Okay, so here we have to multiply in the starting case, that is we have to pre-multiply the A inverse. Now what I will do here, I will just take the separate terms here. This is A inverse into A, this is B, so AB whole inverse. So we know that the A inverse into I is nothing but what? The same matrix I am going to get here because of the identity law. So here this A inverse into A, I can write it as, again it's a, by the definition of this, that is a I here. This is because of the identity law. I can represent with the help of this. Now what is the next step? So here is also the same thing. I into B is nothing but what? It's a matrix B itself. So the remaining term is what? It's a B into AB whole inverse is equal to A inverse. Now the next thing is what? I'll pre-multiply by B inverse on both the side here. Suppose means what? I'll multiply B inverse on both the side at the starting point. So this is AB whole inverse is equal to B inverse A inverse. How we have got this? By pre-multiplying B inverse on both the side. I'll multiply B inverse at the initial point here. Okay. Now again this B inverse into B is the same, it's a matrix I because of the definition of the invertible case. So this B inverse into B is nothing but it's identity matrix what we are getting here, that is I. So this is A into B whole inverse, that is a B inverse into A inverse. Again the thing is what? If I take any one matrix here, if I multiply with the identity matrix, I am going to get the same matrix itself. So I can take this AB whole inverse, I am getting the same matrix here. This is because of the identity law. So from this we can prove that, so AB whole inverse can be written as B inverse into A inverse. If you like this video, please comment, share with your friends and subscribe to our channel. Thank you.